let's see here. This is so I'm giving you the hypothetical that you do the integral of f prime over f of z, and you get the 2 pi ni for this nth order polynomial, right? But remember, what does f prime of z over f of z count? It counts the number of zeros, right? And the number of singularities for f. But f is polynomial. It only has zeros. Therefore, this counts the number of zeros inside the circle to be n, which means that f of z must be non-zero outside the circle. That's all I'm saying here. So what can you say about f of z for z greater than r? I think I should say f of z not equal to 0, right? Let's see here. This one is a pretty standard half circle residue theory based calculation here. I said you can focus on the part of the calculation. I didn't force people to show that the piece that limits to 0 is 0. I just wanted the calculation. I sometimes do that, like here. Find the Laurent series expansion. So this is like the last test. We had a problem like this that was a little bit easier on your test, but same spirit. So to find the Laurent series based at centered at 2, I need to create z minus 2 factors, and then once I do that, geometric series works. And then if I'm outside the disk of radius 1 centered at 2, I must basically factor out the z minus 2 squared there. And when I do that, I get that. But then I can do geometric series because I'm entitled in that context to do that, which then gives me this. So that's the Laurent series out there. So pretty standard example. Oh, interesting. I didn't remember I did this. I must have talked more about algebras last year. I suppose the regular representation of the algebra has this form. I haven't talked about this in this class. I'm not going to put this on you guys. You can relax. Proof is an open set. I didn't do this to you guys, so relax, okay? I'm not going to have you prove an open set this semester, so relax about that. 21. So this is, you got a curve. It loops around these two singular points, and I tell you the value of f at the singularities respectively, right? So you can calculate the residue by like rule 1 or 0 or whatever, and you get respectively 25 minus 4 over I pi, which gives you 2 times 21, which is 42. That's funny. And then this one, I'm like, here's a function f of z. Find the order of the pole for g of z equals to f of z to the 7th at infinity. So I look at g of z, I take it to the 7th power, I get 42 plus dot stuff, which means that if I look at the reciprocal function, h of w is g of 1 over w, I get 1 over w to the 42, which means that you have a pole of order infinity. Order 42 at infinity for f. And then the other one, to find the residue of f of z is equal to 0 for 1/28 z plus z squared exponential 1 over z. So I just have to multiply that junk out and look for the reciprocal term. Lo and behold, it's a 1 over 42 for that. And then, let's see here. I have z to the 100th power plus 37 z to the 58 plus z squared plus z plus 1, blah, 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 blah. So I do Roche's theorem, and lo and behold, there's 42 zeros outside the unit circle. What do you know? And then 25, I've got this g of z is z to the 4th minus 16, integral 1 over pi f of z dz. Union of the counterclockwise oriented circle, z equal to 3 in the counterclockwise oriented circle, z minus 2i equal to 1 wrapped around 7-fold times. Interesting. Wonder why that's all there. So if you work through that, you get this residue, and lo and behold, the answer is 42. And then finally, the last question on the final. If you had to guess, how old do you think is my wife? I had a few brave students give the correct answer here, but I had other people tell me 30. So.